My name is Alexey Soshin. I'm a solution architect at Depop. And today we're going to talk about writing your own feature, or as it's now called, a plugin in Ktor web framework. If you ever used Ktor, you probably also used one of its features or plugins, but I found out that the documentation for how to develop your own plugins is a bit lacking, and I wanted to demystify some concepts around it. But first, briefly about Depop, the company I work for currently. Depop is a marketplace for fashion. We have about 25 million users globally, 30 million items, and more than 100,000 items added every day. In terms of engineering, we are about 100 engineers at the moment and around 200 microservices, which are mostly written in Scala. For the past half year, we were evaluating adding KotLand to our technical stack on the backend. There are a number of reasons for that. First, KotLand is easier to learn than Scala, especially for developers that aren't coming from a functional background. Second, we are using Play framework for Scala, and it frankly isn't the fastest framework. It's not well suited for something like proxying lots of API calls. At Depop, we embrace the backend for front-end architecture. For those that aren't familiar with backend for front-end pattern, its idea is pretty simple. For every major action or screen you have on your device, you provide a single gateway that will produce the results in the best format possible. So we have about 30 of the services that serve all our major functions. And each of the backend for front-end services will receive a call from a mobile or from a web application and will reach out to multiple internal services. So the goal of the backend for frontend is first to proxy the calls to other services, then to combine the response and return it in the for the device. And as I said, currently this is all written in Scala and Play framework, and it's not the best technology for this use case. Of course, we could rewritten our BFF layer using another Scala framework, but we decided to try KotLand and Ktor instead. We chose Ktor because it's idiomatic, productive, and performant enough for us. One of our main requirements from this experiment was that the new services would report the same metrics as the Scala ones. We have a lot of tooling built around our monitoring, like auto-generated Datadog dashboards, and ideally, we wanted to reuse all of it. So our main problem wasn't really KotLand and Scala. Our real problem was the Datadog. Monitoring is just one of the cross-cutting concerns any framework needs to address. There are many others. Logging, templating, headers, authentication, content negotiation, and so on. Doesn't matter which backend framework you use, you will need to handle lots of those cross-cutting concerns. Different backend frameworks have different approaches for handling those concerns. Spring Boot, for example, is notorious for using annotations. If you ever used Vertex, then you know that it uses mostly generic handlers, which is basically a chain of filters. And Ktor takes third approach, which it calls plugins. And plugins is basically a typed filter chain. So if you work with Ktor, Ktor has a built-in solution for almost any of the cross-cutting concerns we discussed at the moment. There are plugins for monitoring, for logging, for different templating engines, plugins that send particular headers, handle core, plugins for authentication, plugins for marshalling and unmarshalling responses. Lots of plugins, but the problem is that most of them are developed by JetBrains themselves. And if they don't particularly suit your needs, there aren't many examples currently how to create your own plugin. So as I mentioned, there are already a couple of metrics plugins for Ktor, but they didn't suit our needs. They weren't reporting the metrics exactly the way we wanted them to do, and it took us too much effort to set them up so they would work the way we want them. So we decided to build our own plugin instead. Today, I'll take you through how to build your own monitoring plugin in about 20 minutes or less. I already prepared a project that starts a Ktor server that responds with some text. Sometimes it will also randomly fail. And the response time is a bit random too. So I try to simulate the usual behavior of such a service. We will see how we can implement a custom plugin to monitor this server. In order to do that, I created a mock for our metrics client. If you ever worked with StatsD, it's the same API, but instead of sending metrics to the metrics collection service, it will just print all the events to the console. So here we have three methods: increment success, increment failure, and time that will measure the delta between the request and the response. And each of them will simply output the current timestamp and some kind of a message and the URL to the console. For those that less familiar with Ktor framework, that's all it takes to set up a server. So it's really easy. We specify the port, specify the server engine, and the way we define routing is also pretty straightforward. So in this case, we will respond to any URL because we want to test it on different URLs. And for any URL, we will trigger a random delay, and 10% of the time, we will also throw an exception. Okay, it's time to start. So first thing we need to do is to install our plugin. That's the way Ktor handles the plugins. That's how you add them. So let's start. We'll use the install function. And here comes the name of our plugin. So let's call it server monitoring plugin. Let's see if IntelliJ is smart enough to generate it for me. No, okay, doesn't matter. We'll do that manually. So first thing we need to do is we didn't declare this class at all. So let's go and declare it. That's our class. Doesn't do anything at the moment. And now we get a hint from IntelliJ that tells us that this class needs to have a companion object. For those who are not familiar with companion objects, this is basically a static factory method that we need to implement. So we don't invoke constructor on that class, but this factory method will initialize the class for us. Okay. Sometimes it gives more useful suggestions, but we'll do what we have. So we declare companion object. And now this companion object will have to implement a particular interface. So each feature, things like Ktor server, Ktor client, and so on, have a different interface that you will need to implement in order to develop a plugin for that layer. So our server tells us that we need to implement that particular interface in order to be a plugin. And that interface has two methods. I know that the signature may look a bit scary, but don't worry, we'll explain that in a second. And first, let's try to understand what's the goal of that part. So the way it works is that we basically need to operate on something, and that something will be an application. We also need to return our plugin. So that's the third type we take. And the second type, the one I left empty, is the configuration we need to pass to our plugin in order to be initialized. So let's call it just config. So again, first type is what we operate on. Last type is what we are, what we return. So in this case, this is similar to the class of our. And for configuration, we'll just create currently an empty class. So let's say, let's delete this part. And we will let IntelliJ to implement our methods again. Okay, now it should be a bit more clear. I think that the hardest part to understand how plugins work, this free-typed signature is behind us. So we have two methods to implement. Let's start with the easier one. Key is a simple identifier for our plugin. You can think of it like that. Ktor has a map of all those attributes, and each plugin adds itself to that map with its key. So we know we need to be an attribute key. And you'll see that it takes a string. But the string is actually just for debugging. It's not used. What actually is used is the attribute key itself. And you see that the attribute key is typed by the type of our plugin. So this means that only the plugin itself can register its type. It's a very smart way to have a type-safe registration. So Ktor holds all those plugins, but only the plugin itself can say, hey, I'm plugin named server monitoring plugin, please register me. So that was about the key. The key is just to identify ourselves. The most interesting part is the install function. It's where all the stuff happens. But before we start implementing anything in the install function, let's go back and pass the client to our plugin. So I mentioned that we have this metrics client. This is just a mock client. And we need to pass it to our plugin. So let's do this. So we say that in this block, we want to pass the client, the metrics client, to the plugin. Now, in this block, we are in the scope of the config class. You've seen me declare that class as empty a few minutes ago. Now let's add a property to that class. So this property needs to be mutable, and you have two options to declare it. One option is to declare it as late init, as I did now. This is what also IntelliJ suggests. Another option is to declare it a variable with some default value. But I go with the late init now. So let's go back to our install method now. We have the mock metrics client that we want to use in our config. To read that config, we will use the apply function. We'll create an empty config. And then we will invoke apply on the block that was passed to us. That's quite a common pattern in Ktor. You copy everything that was passed to you, and that way your code will also remain thread safe, since the configuration is a mutable object. So now we passed our metrics client to the temporary config, and we have it in our install method. The last thing we need to do is to return our plugin. So we promised that we return it. We need to keep that promise. Now our code should compile at least. And it has the configuration the user of our library of our plugin has passed. Let's see that everything runs. So here I have a test for those that aren't familiar with how Ktor is tested. This is the actual test that I will run. And this will create a test module. So In some cases, you don't want to install all the plugins and you want to test only part of your system. So you will create a test model that is a smaller replica of your real model. So let's see once that it runs without our plugin. And now we will install this plugin in our tests. And see that everything still works. We didn't change much yet. We just installed a plugin that doesn't do anything. It is now time to go back and discuss theory some more. So request in Ktor has a life cycle, and this life cycle is represented by an object called a pipeline. In the pipeline for the server, we have a setup phase where Ktor prepares the call for us. Then we have a hook for monitoring. Then all the parsing features kick in. And finally, we have the call phase. And actually, there are two identical pipelines, one for requests and another for responses. So we go through one when we receive a request. Usually we transform bytes into some kind of an object, and then our business logic returns some object again, and we need to transform it back to JSON or something else, and also set the correct headers, for example. That's why we have those two pipelines. And every major feature in Ktor will have some notion of pipeline. We will focus on the monitoring phase of the request pipeline now. So we will install our plugin here. If you look at our code, you can see that the first argument, as I said, the type we operate on is already called the pipeline. And to add a logic to a certain phase, we use function intercept. Now we need to pick the correct phase. And that will intercept our pipeline, our request, at monitoring phase. Now you can go and see how this object is declared. So you can see that it declares all the steps. This is the order the steps will kick in. And for each phase of the pipeline, you also have a short explanation of what it does. So for each of the major features, you'll have a similar setup. Now we intercepted our pipeline at the monitoring phase. To continue to the next step, we use proceed. In some other languages or frameworks, you may be familiar with next function that does the same. It just goes to the next step without doing anything. Nice thing about KotLand and Ktor is that we can use regular structures such as try-catch, and we don't need to mess with monads and stuff like in some other languages and frameworks. So that means that we can wrap the proceed in a try-catch block in case the business logic, for example, throws an exception. Let's say that if everything goes fine, we want to invoke some success logging or monitoring. So we will invoke it on our plugin. And to this function that we didn't declare yet, we will pass a call. So call is our request. If something went wrong, we want to invoke failure function in a similar manner. But we'll also pass it an exception that we received. Now let's see how we can implement those. So we want to access the config, and we want to access the client inside the config. Let's pass it to our constructor. Now our plugin has the mock metrics client that we can use. So in the success, we want to increment success, and we want to do that with call request URI. And for the failure, we want to do the same, but with the increment failure, and we will also pass the exception. So that's it. Let's see that it works. You can see that now it prints success, hello, that's the URL our test invokes to the console. Let's run it another time and see if we get an exception. Still okay. So that's one part. We implemented monitoring for success or for failure of our server. The way we did that, we passed the client during the installation of our plugin. Then we invoked apply to create an object from that block, and we passed it to the constructor of our plugin. Another thing we want to implement is the time function. So we want to measure how much time it takes for our service to respond. We'll approach that in a similar manner. So we'll have another function that we call before the request starts, just after the request arrives. And we'll have a finally block. When we invoke the after function. Now let's think what we need to do. Before any request starts, we want to save the time when it started. On the call object, there is an attributes object. Attributes is basically a map that allows us to store values that will be discarded after this request is finished. So we will put on that map data about our metrics. Let's create a new class. And the only value we need to store is the current time step of that request arriving. Now we know what the value we put in the map. What is the key? So let's see if IntelliJ is able to help us there. You can see this is again an attribute key, similar to what we used to register our plugin itself. Again, the string is just for debugging, but you can and should give some explanation what this attribute key stands for. So what we did, we again put a typed value in our map. Now we need to somehow fetch that value. Let's see how we do that. So we want to access the attributes. There are two benefits of the pattern. First, it doesn't use something like a thread local because Ktor is using coroutines and you cannot rely on threads. And second is that this is already typed. So we get exactly the type we want. So this is already of the type of metrics. Now let's log it using our client. And you see that auto-completion works fine because it already knows what type of object we received. So what we do here is that we fetch the value we put when our call has started. Then we calculate the delta between the current timestamp and the new timestamp, and we report it. Let's see how it works. So I'll run my test again. And you can see that now it reports the delta as it should. Let's try to see if we can reproduce the error now. So I'll just always throw an error. And now you can see that our plugin also reports errors, and it still keeps track of how long it took us to serve that request. Okay, I think it's time to summarize what we achieved now. So in about 20 minutes, give or take, we implemented a client, a plugin that is able to monitor our server application. We monitor the server success rates and timings. When you decide to create your own plugin, you need to first decide on which pipeline to operate. Each major feature has its own pipeline with its own phases. Then you add a companion object with a key property to register the plugin and an install method that wraps the correct pipeline at the correct stage and returns our plugin. So in this case, we wrap the application pipeline and we return our plugin. This is the code. As you can see, about 60 lines of code, that's all it took us. If you want to proceed to the next step, or you don't want to do anything in some cases, you just call the proceed function, and it will invoke the next stage, the next of your pipeline. All the code can be found on my GitHub. So there is the final version and also the initial version if you want to practice developing your own plugin yourself. If you'd like to stay in touch, this is my Medium, Twitter. I also have a course on Udemy that is luckily pretty popular now. So take a look at it. And this is my book. Last thing I want to say, please don't buy it now because I'm working on a second edition and it will be published in November this year. Thank you so much for attending my talk and good luck developing Ktor plugins. Thank you.